Allotropes are compounds of the same element, but they have a different structural arrangement. So we're going to look at three groupings here. Certainly diamond is a compound. Graphite is actually sheets, loose sheets of graphene, and pyrolytic carbon we're actually not going to cover. Fullerenes are also a range of different compounds as well. So let's get into the carbon allotropes here. So the first one is diamond. Diamond is the strongest natural substance known to man. So the fullerenes are man-made and they're actually stronger than diamond. So each carbon is bound to, has 4 bonds, bound to 4 other carbons. So this is the melting point, 3,550 degrees, very high, very difficult to break because there are strong, stable covalent bonds interlinking quite strongly. And so those electrons are held in place. So of course it's not going to conduct. It's also not going to dissolve because those bonds are too strong and they're not going to be broken down by any solvent. Now, still made purely of carbon is graphite, which has completely different properties. So graphite's only bound to 3 other carbons in the lattice. And the difference is this graphite is actually sheets of graphene that pass over each other. Now, if you just have a single layer of graphene, it's extremely strong like carbon. But graphite is basically lots of broken pieces. And so they slide over each other, and electrons can actually pass in between here because electrons are free in these orbitals right here. So they're very, both made of carbon, very different. One conducts, graphite conducts electricity, whereas diamond does not. Graphite is also very slippery. It's used in pencil leads or a lubricant, whereas diamond is quite hard. It's actually used to cut other diamonds or other materials. And so it has a very high melting point and it's insoluble. Over on to the third one here are fullerenes. Now, fullerenes are, again, just pure carbon. They are man-made. We're still working on those techniques, and they are actually stronger than diamond itself. They can also conduct electricity, and they are also can form various shapes. So buckyballs are round, nanotubes are tube-shaped, and they're trying to work on other shapes and putting them together to make nanomachines that can't be seen. And so the last type of fullerene here is a buckyball, which is carbon C60. So that, again, it conducts electricity, has super strong covalent bonds, and is a very strong material. So they're the 3 allotropes of carbon. There are other allotropes of other materials, such as sulfur, that you could research if you're interested.